Isaac Newton was born in 1643, Woolsthorpe, United Kingdom, as the son of Isaac Newton Sr. and Hannah Ayscough, and died 1727 in Kensington at the age of 84. He entered Cambridge University in 1661, where he would eventually take the position of a lecturer until 1696. Despite claiming to be self-taught, he was an avid reader of the works of his compatriots, William Orchard and John Wallis. Sir Newton's most recognised contribution to the world of mathematics is no doubt his work on differential and integral calculus, discovering methods to determine the function of x's gradient at any given point on a curve. These methods are the basis of all calculus, and publications of his works were well received in the scientific community. Newton showed that he also valued science above religion, as he challenged King James II's attempts to Catholicize Cambridge University, despite being a devout Christian himself. He was successful and was elected as a Member of Parliament as a result.
Newton needed to solve practical problems involving rates of change of different quantities which varied with time. He developed differential calculus for finding these rates. This involved taking the rate of change of some variable over an interval, in the limit as the size of that interval approached zero. Newton was working with time derivatives with concepts such as displacement, velocity, and acceleration. He used x dot notation, which was later changed to x prime by typesetters, but this notation is limited as it only allows for differentiation with respect to one variable. For this reason, Leibniz's dy dx notation is most commonly used today. The same methods which Newton developed are applied today throughout physics as well as in many other areas, such as engineering and economics. Since Newton's time, calculus has been extended with concepts such as partial derivatives and has now become one of the largest and most widely used areas of mathematics.
So Isaac Newton faced many obstacles like any one of us. Some obstacles he faced to get his work accepted were the critics in the scientific community. Arguably his biggest critic, other than himself, was Robert Hooke, who thought Newton stole his and other scientists' ideas on gravitation and planets. Robert Hooke never really did back up these claims, but still their conflict remained. But Newton's biggest beef was with Gottfried Leibniz, over who actually created calculus. Although Newton is known to have worked on it earlier, and even called out Leibniz on it, they are both credited. But Leibniz's notation is more widely accepted due to how convenient it is.
Philosophia Naturalis Principia Mathematica, or simply Principia, is a set of 3 books written by Newton. First published in 1687, the works consist mainly of Newton's laws of motion, classical mechanics, and the law of universal gravitation. The books are considered by many academics to be the epoch of a great revolution in physics. In formulating these theories, Newton explored the use of early calculus. However, the language and notation we use today is absent from this text, as Newton gave his proofs in an early geometric form using infinitesimals. Method of Fluxions is Newton's book on differential calculus, published in 1736, with fluxions being Newton's name for the topic.